Hello students. So we've come to another topic which is limits to accuracy. This is a very useful topic for those of you doing physics. And some of the topics that you're going to be tackling, they involve you rounding numbers to significant figure. Remember, when we're expressing numbers in standard form, we encountered a very large numbers and we had to round them off. So in some instances, we might keep the percentage error when you round up, so that when you're presenting your data to maybe a panel of scientists, maybe a panel of colleagues, you must be careful to state the error that might be involved in your answer. So for example, if you have your meter rule, if you have your meter rule here, if you have your meter rule starts at zero, and you're going to have these small divisions. Four of them, then you have one for the middle, then you have another 4 divisions before you have your one. Before you have your one. So if you're asked to measure something and your reading comes to this point, it comes to this point. So this reading, it's neither 0 point, it's neither 0.5, it's not 0.5 exactly, or 0.4. You can't tell because it's in the middle of the already marked readings. So it's neither 0.5 or 0.4. But when you are looking at this reading, remember you must look perpendicular so that you do not cause a parallax error. So when you're looking at this reading directly from the top, you assume if this reading is past 50%, you assume that this reading is 0.5 by just assumption because the ruler is not marked. So this means if you assume that this reading is 0.5, you have added some error into your reading. And when you calculate larger values using this base value that you have added, the error is only going to compound. So it's important when you're using a meter rule, to state the accuracy of the instrument so that when you present your findings, you must also present the degree of accuracy. You must also present the degree of accuracy. So let's have a number. For example, you have 0.34578 is a number, and you are asked to round this number to 2 decimal places. You are asked to round this number to 2 decimal places. So if you are asked to round this number to 2 decimal places, you count the first decimal place, second decimal place, then you look at the third decimal place. If the third decimal place it's more than half, this one moves a unit up, which means you're going to have 0.3, you're going to have 0.35 as your final reading. You're going to have 0.35 as your final reading to 2 decimal places. So, as scientists, you have made that assumption that your reading is 0.5 to 2 decimal places. You're also going to highlight that you round up to 2 decimal places. You must also remember that this one carries an error of plus or minus. How many figures have you rounded off? You say 0 point, you take 1, 2, 0, 0, 5. You have to add or subtract this one because you have looked at this number and you see that this number is greater than 5. That's why this reading became 3.5. So this is the error that is associated with the number. So if you are asked what's the maximum possible number, what's the maximum possible reading for this, the maximum possible reading will be the one with plus, which is 0.35 plus 0.005. And what's the minimum possible value of this one? The minimum possible value is going to be 0.5, 0.35 minus 0.05. So this will be the maximum possible value, and this will be the minimum possible value. So let's assume that this was the reading for a cardboard box, or a plane shape, let's say a plane rectangle, and this was the reading for the height. This was the reading for the height. This was the reading for the height. And you are asked to find the area. So when you're asked to find the area, you use this one. Then you find the area. But remember, the area contains this error. So you might be asked the question, find the maximum possible area. So if you are told to find the maximum possible area, you use the larger value. Let's say if this is a square, you're going to say length times width, which is equals to, you take the largest value, which is 0.355 multiplied by 0.355. This one will be the maximum possible area. The minimum possible area, you take the lower value of your reading. That will be the minimum possible area. So you must be well acquainted with this method. Make sure that if a number is given as 3457208, and if a number, if you're asked to round this number maybe to two significant figures, that's going to be 25. That's going to be 2,500,000. Yeah, let's see how this is. 2,500,000. So it's going to be 2,500,000. But you must remember that you rounded this to two significant figures. So you looked at this number. That's where the error is. So this number will be 2.2 plus or minus where you made your round off. That's where the error is, where you made your round off. So let's move on. We're going to do a tutorial where we're going to tackle some of the questions involved and some of the questions that you're going to be asked. But mostly they are going to give you certain dimensions of a plane shape, or dimensions of a cube, or the radius of a sphere or of a circle, which